We have the equation 3 cosine plus 3 is equal to 2 sine squared, where x is in the interval from 0 to 2 pi. So in order to solve this, I want to make sure that we can have both sides of the equation in terms of either cosine or sine. So the easiest way to do that is to notice that sine squared plus cosine squared is 1. So then sine squared is 1 minus cosine squared. So I'm going to make that substitution. On the left, I'm just going to leave it alone. We have 3 cosine plus 3. And on the right, sine squared will be replaced with 1 minus cosine squared. So it's 3 cosine plus 3. We're going to then distribute the 2. That's 2 minus 2 cosine squared. I'm going to choose to bring everything to the left. So that means adding the 2 cosine squared and subtracting by 2. So we have 2 cosine squared plus 3 cosine x plus 1. And we're going to set that equal to 0. So you can kind of think of this as a quadratic in disguise. You know, if you have, for example, 2u squared plus 3u plus 1 equal to 0, well, what you would do is have 2u and u to get 2u squared. And we know that 1, the only way to get 1 is 1 times 1. So then you would add these, and you set that equal to 0, and then you set each one equal to 0. But before I do that, I'm just going to replace here u with cosine, right? Because that's the substitution we made. So this would factor into 2 cosine of x plus 1 times cosine of x plus 1. Set that equal to 0. So you have 2 cosine plus 1 equal to 0. Cosine plus 1 equal to 0. So here we have to be mindful that we have to be in the interval from 0 to 2 pi. Cosine is then negative 1/2, and cosine is negative 1. Let's draw a unit circle just so we have a good idea of when is cosine negative 1/2 and negative 1. So because they're both negative, we know that we're going to be in the second and third quadrant. So cosine negative 1/2, that's going to be up here somewhere and down here. So this is going to be 2 pi over 3 and 4 pi over 3. And the cosine is negative 1 only at pi. Okay. So we just need to combine these three answers to see when the original equation was equal.